Hey everybody, this video is just me going over problem 13 in section 4.1. It's on page 171, I believe. It was just requested that I go over this proof because proofs are hard. So this proof says if two angles are congruent, then their complements are congruent. The given is angle ABC is congruent to angle DEF, so we need to prove that the complement of angle ABC is congruent to the complement of DEF. So the first way we start any proof, we're just going to put a line down the middle. Statements on the left, reasons on the right. The first statement should be pretty doable. That's simply our given. Our reason for that also should be pretty obvious. It's given, right? Our final statement down here should also be pretty doable without spending too much brain power. We can simply copy down the statement of the thing we're trying to prove, right? So I'm going to put that right down there. The complement of angle ABC is congruent to the complement of angle DEF. So now we just need to fill in the intermediate statements and give reasons for everything. Whenever we see something written out kind of like a sentence where it says the complement of angle DEF, we should think of, oh, does this little sentence or does this little description, does this contain one of our like vocabulary words, right? In this case it does, it's the complement. So we should think, oh, maybe one of the reasons over here on the right should be definition of complement. So this is a likely reason for us to get here. How do we get, what information allows us to use the definition of complement to call it the complement? So what is the definition of complement? Complementary angles are angles that add up to 90 degrees, but more specifically, we're not asking for definition of complementary, we were asking for complement. So the complement of an angle, you can find this on actually just problem like 10 and 11 in the, flip back another page, is, in this case, I'm going to type it out, 90 minus, I'm just going to say angle, angle ABC, right? That'll give us, this is the complement of angle ABC. And we know the complement of angle ABC is congruent to the complement, which is 90 minus angle DEF. So all I did here is instead of saying the complement of angle ABC is congruent to the complement of angle DEF, I'm going to say that the 90 minus angle ABC equals 90 minus angle DEF. In fact, let me reword this a little way. I'm going to say the measure of, we have an angle, we'll use this. We'll say the measure of angle ABC, because this is a number. We can actually do math with this. Similarly, we have 90 minus the measure of angle DEF. And this leads us to this step using the definition of complement. Cool. So now the question is, how do we get here from up here? And we can throw in another step here. Since we're dealing with congruence, we're going to need to change it into equality so we can do some stuff with it. So I'm simply going to change that congruence statement into an equality statement. Similar to before, I'm going to say the measure of angle ABC is equal to the measure of angle DEF. Right? How do we get from there to there? Well, that's the definition of congruent. So because these two things are congruent, their angle these two angles are congruent, the measurements of those angles are the same. So that's where the equal sign comes in. So now how do you go from here to here? Hopefully, most of you guys can get from here to here pretty easily. I'm going to draw an intermediate step. There's only one intermediate step I'm going to put. That is the measure. I'm going to put a negative measure of angle ABC equals negative measure of DEF. Yeah, we'll use capital. Cool. How did I go from there to there? Well, I either divided both sides by -1 or multiplied both sides by -1. So we can use the multiplication property or division property. In this case, I usually think of it as multiplying by -1. So the multiplication property of equality. And then how do we get to this one? What are we doing between this step here and this step here? Well, all we're doing is adding to both sides 90. So can we add something to both sides? Yes. This will give us the addition property of equality. So this is it. This is our proof. We start off here. Angle ABC is congruent to angle DEF. We change it into an equality by saying the measure of angle ABC is equal to the measure of angle DEF, right? Using the definition of congruence. Then we can just multiply both sides by -1. The negative measure of angle ABC is equal to the negative measure of angle DEF. And then we could subtract both of those from 90, or add 90 to both sides, essentially, right? 90 minus the measure of angle ABC equals 90 minus the measure of DEF. And then finally, we can say the complement of angle ABC is congruent to the complement of angle DEF, because this right here is equal to the complement of each one. That's our definition of complement. So that's it. That's the proof. We start up here. We turn it into an equation. We manipulate the equation a bit, and then that gives us the complement. But key is we're doing it to both sides, right? Okay, I'll pause there.